Hello everybody, welcome back to Simply Space. Today's topics we'll be talking about are the distance modulus, redshift, galaxies, supernova, and the Hubble diagram. So first up is distance modulus. But before we get into that, first we need to define what parallax is. Parallax is the difference in the apparent position of an object viewed along two different lines of sight. Imagine two objects with a few meters apart, with one in front of the other. If you were to walk by these objects, it would appear that the object further in the distance moves more slowly than the closer object. So a nearby star's apparent movement against the background of more distant stars as Earth revolves around the Sun is referred to as star parallax. The distance modulus makes use of parallax. It is the difference between the observed brightness and the absolute brightness of an object in outer space. This provides the measure of the distance to the object. Next up is redshift. Redshift can be defined by when an object moves away from us, its light waves are stretched into lower frequencies or longer wavelengths, and we say that the light is redshifted. In the visible portion of the electromagnetic spectrum, blue light has the highest frequency and red light has the lowest. In physics, redshift happens when light or other electromagnetic radiation from an object is increased in wavelength or shifted to the red end of the spectrum. In general, whether or not the radiation is within the visible spectrum, redder means an increase in wavelength equivalent to a lower frequency and a lower photon energy, in accordance with, respectively, the wave and quantum theories of light. A common example of redshift is the fire truck example. If the fire truck is coming towards you, the time in between the sirens sound like they're shorter and the pitch sounds higher. But if the fire truck is moving away from you, the sirens sound longer and the pitch sounds lower, or sounds like it drops. The next topic is galaxies. There are three main types of galaxies in our universe: elliptical, spiral, and irregular. Elliptical galaxies get their names because they have elliptical shapes. They look like fat, fuzzy eggs or footballs. Elliptical galaxies can range from spherical to elongated, football-like shapes. Stars in elliptical galaxies do not spread out into a thin disk, as they do in spiral galaxies. Instead, they wrap evenly around the galaxy center in all directions. The reddish color of elliptical galaxies tells us something important of their histories. The galaxy's red color comes from older, cooler stars. The fact that most of the light comes from old stars suggests that most ellipticals were formed a long time ago. The fact that the color of an elliptical galaxy is more or less the same throughout the galaxy suggests that most of the stars in these galaxies formed around the same time. Like the one shown, spiral galaxies have flat disks of stars with bright bulges called nuclei in their centers. Spiral arms wrap around these bulges. These spiral arms contain stars and dust, and in the center of spiral galaxies generally contains a black hole or superblack hole. The third type of galaxy is irregular galaxies, and irregular galaxies are classification for galaxies without symmetric shapes and no clear bulge or disk. Next up is supernova, and a supernova is the explosion of a star. In this explosion, more energy is given off than our sun produces in its lifetime, and enough light is created to outshine an entire galaxy. Supernova discoveries are reported to the International Astronomical Union's Central Bureau for Astronomical Telegrams. The name is the marker supernova followed by the year of discovery, suffixed with a one- or two-letter designations. One of the types of supernova are type 1a supernova, which are caused by the accumulation of matter between a carbon-oxygen white dwarf and its pair in a binary star system. The white dwarf continually gains matter as its core becomes increasingly dense. At times, the star can become dense enough to explode in a supernova. Type 2 supernova are the result of the death of a massive star. The star, near the end of its life, depletes its nuclear fuel and is unable to support itself, sometimes collapsing in its iron core and producing a supernova. The last topic is about the Hubble diagram. Hubble's law describes the observation that objects in deep space are found to have a Doppler shift that can be used for determining distances of outer space objects. In order to depict Hubble's law, a Hubble diagram can be constructed. This diagram plots an object's velocity, which is directly proportional to its redshift, with respect to its distance from an observer on Earth. This diagram appears as a straight line of positive slope. Hubble diagrams are used by cosmologists to determine the measure of the distance of celestial objects from Earth. The diagrams take advantage of the properties of the redshift in order to calculate and present these distances. Thank you for watching our video on the Hubble diagram. If you want more information on anything discussed today, please visit our website by clicking the link in the description below. If you liked this video, please like and subscribe to Simply Space, and we will see you next time with a new space topic to simplify.